So that means that we have to recall the postulates of quantum mechanics and think about what they would be in terms of this density matrix rho. So at this point, I hope that you could all write down the 4 postulates of quantum mechanics in terms of wave functions. If not, that's a good way to quiz yourself. Let's try to do it in terms of this new object that we have, though, with the density matrix rho. So it's going to be the same thing, roughly. It's just that we have a psi on either side. So whatever we do to, before we just had ket psi, we'll also have to do that to the bra psi. So we're kind of, in a way, doing the postulates from either side. So the first postulate, though, P1, is just that this is the mathematical object. So the most general quantum state will be this density matrix rho, which I'll rewrite as a sum over I, pi, outer product psi I, where what's going on here, the sum over I of pi is equal to 1, and each psi I is a valid quantum state, so it has norm 1. Now let's think about the second postulate. The first postulate tells us what quantum states are. The second postulate tells us how quantum states evolve, how they evolve in time. So with just a single ket psi I evolving unitarily, it goes to u times psi I. In the case for density matrices, rho will evolve as u, rho, u, dagger, where u, dagger, u is equal to the identity u is a unitary matrix. Do you see why this would be the case? It's because each psi I is going to evolve to u times psi I. So that happens for the ket, and that happens for the bra. I have the linearity principle, so I can pull it out of the sum and outside the coefficients and write the whole thing as u, rho, u, dagger. Okay? So it's just still the same second postulate applied to the wave function psi, but now we're just writing how it affects the density matrix. In this case, we need to conjugate the density matrix by the unitary u. Similar thing will happen with postulate 3. So I'll write it down for you, and then I'll justify it. The probability of getting a measurement outcome m will be the trace of dagger times rho. Remember, so this is our general measurement postulate. The measurement operators m sub m are any operators which satisfy the completeness relation. Summing over them in this way gives identity. And then the state update rule will be that rho immediately after a measurement gets mapped to the state rho, dagger. This time, you can think of each psi contributing a square root. So the total normalization is p of m instead of the square root of p of m. The last postulate is just tensor products as usual. So that is rho 1 tensor rho n is the composite state of the individual constituent states, rho 1 through rho n. Any questions about the postulates in terms of density matrices? Let me justify quickly one of them for you. So let's see why this is true. I sort of said it out loud for the unitary evolution, the second postulate. But for measurements, imagine for a single wave function, we know the rule starting from the third postulate as before. This is psi, dagger, psi. And then I can rewrite this, again, using the same rule, trace of dagger, psi, outer product, psi. So that's essentially the intuition. And then you just have to use the linearity property to do it for all of this. So, as we'll come to know it as a mixed state, now if I have rho being the sum over I of pi psi I, then I just do this individually for each one, and I use the linearity property. So formally in this case, the probability of m will be a sum over I, the probability of measurement outcome I, conditioned on the state being in system I, times whatever the probability of outcome I is. So this I can write as, again, sum over I. The pi won't change. That's just going to be our pi that appears here. And then probability of outcome m, assuming we're in the state psi I, is this one, psi having a subscript I. So let me write that in. This is pi times now the trace of dagger, psi I, outer product psi I. Now I use linearity of the trace to write this as the trace of dagger, now in parentheses, sum over I, pi, psi I, outer product psi I. And this, of course, you recognize as a density matrix rho. So that's the justification of this third postulate in terms of density matrices.